This conference will now be recorded.
Hello friends, welcome to the demo session on data science. We'll start the session. I hope you are able to see the screen
Yes, I can see.
and able to listen to my voice.
Yep.
One quick thing, I just want to, just a second. All right, so I'm set. So I would recommend everybody, if you're not speaking, you could go on mute so that it would not hamper the session. So today we'll do an important topic. We'll look at how this entire data science life cycle would work. We would work on the end-to-end life cycle of data science. We will see what are the important areas which will be covered, and that will help us to solidify our understanding of data science. And in our course, we would also discuss about the details of this sub areas. So let me take my blue screen. Most of our course we would be using this either the blue screen or the white background screen. I would like to do sessions like extempore sessions where we will learn about the concepts as and when we go, and for understanding the practical aspects we would do a lot of projects. At least we'll cover 20 projects throughout the course, so that as we are covering all the projects we will understand the usage of data science in the real world. Let me end to end. Data science life cycle. Okay, so we'll say the topic is end-to-end data science life cycle. So if you have any questions in middle, what you could do is you can use the chat window. There is a chat window available. You can put your questions in the chat window and I will take the questions and answer them at the right time. If you really wanted to talk and ask questions, then what I would recommend is you can unmute yourself and then speak, but just ensure that you're not kind of interrupting anything in the middle, right? I hope you could do that. So end-to-end data science lifecycle, what we're trying to see is like how this entire data science lifecycle started, what are the different components of it, and what will be covered. So initially, the data analysis was happening as a standalone piece. Imagine there is a system, a business which is doing some, selling some products or something. So they basically sell products and then they used to store the data in technically like RDBMS databases. So we can call them as RDBMSs, or in a general sense they are called as ODS, operational data stores. Operational data stores typically store your regular information. So if I take an example of a retail store, so this is a retail store like Reliance Fresh or DMart or Walmart. So this is a retail store, and what is this retail store doing every day is like capturing who purchased what, and what were the transactions, what transactions happened, how many cages of sugar sold, how many liters of oil sold, Likewise, all those transactions are happening and they will be stored in the RDBMS databases. And then in the initial years, what people did was they were writing SQL queries to analyze data. So initial years of data analysis were happening using the SQL queries. People used to write SQL queries on these ODSs or RDBMS databases, and which will help them to understand what is the demand and supply. So people used to run queries on the tables, select queries and some aggregation queries, group by, order by kind of things. And when you do that, what you'll know is you'll know like what is how many kgs of sugar sold, how many kgs of rice sold, how many kgs of something else, right? So we will know like how many products are sold and what is the quantity which is sold. So when we know that information, we can then use that information for future planning. So imagine this month I understood that there are 100 kgs of rice sold, just imagine. Then based on that, I will in the next month also I will plan accordingly. I will ensure that the supplier provides us the required quantity of product, so that I will not get short of the products. Now this kind of analysis was running for a long time, right? Many people were doing this analysis in the early years, and it was running for a long time, and it was very good. But what happened is, as the businesses grew, as there was a lot of transactions happening in the regular business, whenever we run these SQL queries, they were hampering the actual transactions, because when you run these SQL queries, the database gets locked and probably they'll get slower unless until we are not using parallel computing and so on. So when this kind of deadlock happens and you're slowing down the actual business process, it is hampering the SLAs of your transactions. So if you hit a order now, it would have taken like 2 minutes, 5 minutes, and after that the order would complete. So basically it was slowing down the regular transactions. Regular business transactions were slowing down because in the back end there were some SQL queries, long running queries were running, which were locking down the databases or the tables, which was causing the problem to the real transactions. Then what people thought was, okay, because these queries are hampering your actual working procedure of the business, so let us not run these queries during the business hours. So the decision taken was, let us not run these queries during the business hours. So let us define the business hours. So it's a 9 to 5 is business hours of our business. After 5 o'clock, later in the evening, we will run these queries. That's when these nightly jobs came into picture. Nightly jobs. So what are these nightly jobs? The nightly jobs do not run during the day. They used to run in the night, later in the evening and the night, and they will run on the same tables, and they will collate all the information, and they will create the reports and other things. So this also worked for many years. People were very happy because during the day the business used to work. During the night, when there is off business hours, the lean period, at that time the nightly jobs used to work and everything was fine. Until unless the businesses grew beyond the geographical boundaries and the advancement of internet and other things, right? So if you really know, the advancement of internet happened late 1998, 2000, so which is just like 20 years back, right? So beyond that, before that, the systems used to work standalone, and they used to very confined to the boundaries of the geographies and other things. So two important things happened. One is the advancement of internet, because of which these shops are no longer bound to physical locations. Now they are going online. So you could see Walmart, DMart, and other online stores have emerged where you can book products online and other things. That's one part. And second part is these shops or retail stores are not bound to one specific geographical location. Now they have opened their shops in other parts of the world. So the Walmart is open in US, the Walmart is open in other countries like UK, Dubai, and other places. So what is happening is when US is sleeping, the other part of the world is awake. When Singapore is sleeping or where Australia is sleeping, the US is awake. So what is happening is there is no lean period which says that, okay, this is the lean period where the nightly jobs can run. A situation came in such a situation that we can't run these jobs at any point in time, and because of that these jobs were having problems. To overcome this issue, what people did is they created something called as data warehouses. They created tables called as data warehouses, DWH. Now, what these data warehouses used to do is they are kind of a mirror copy or probably a transformational copy of your actual ODSs, the operational data stores. They are the kind of a mirror copy or a view copy or extraction of your actual data. And these nightly jobs, instead of running on the ODSs, they used to run on the data warehouses, right? So these nightly jobs were not hampering your regular working procedure. So the retail stores can work 24/7. The online transactions can also work 24/7 because the ODSs are not hampered by these jobs. These jobs were running on the data warehouses. So the data warehousing systems, since 20 years, we were creating these data warehousing systems. What they do is they will work on this extracted data. Now, while you are doing the extraction, there are a lot of transformations can be done. You can do joins, merges, removal of the columns, adding new columns. So you can do all that good stuff, and you can create a separate data stores where you can run these jobs. Now, when you run the jobs, you will try to create some reports, you try to do some data analysis, you try to get some insights and other things. All those insights can be extracted from the data warehousing systems. So things is working very well. So what people said is, okay, data warehousing is really good, and for many years we are still, even as I speak today, also we use a lot of data warehousing systems because they are very solid. They have a lot of past experience, and a lot of ground research is being done on how this system should work and all. But one thing which the data warehousing systems fail is when storing multiple types of data. So nowadays there is a lot of research happening how to enable data warehouses to store multiple types of data, but that is not a foolproof solution. Data warehouses are very good for storing past data, like it can store for many years, where ODSs were storing the current information. Now, if I want to store 1 year back data, 3 years back data, old data, now data warehousing solutions are the best use for that. So that's the reason they were very widely used. But when it comes to multiple data sources, like different types of data, they are not designed, because they are technically designed as structured data sources, row column format. They look like tables and other things. So they are not designed for what we say is multiple other sources. So when the systems came which requires to store multiple data sources, people created something called as data lakes. Now, what are these data lakes? Now, data lakes are eligible, or basically they are the ones which are eligible to store multiple data sources. So you can store videos, you can store videos, you can store images. Like, let me take another. And this is the only image I used to draw every time. Two mountains and a lake and a house, right? Just imagine this. This is that image. Images. You could have log files. You could have some sensors, sensor data like IoT sensors and other things, sensor information, some text data, right? I could some text files. Now, these are some of them, like I could go and do a lot of other things. You can have data sources like images, videos, logs, sensors, textual data. Like I can combine all these different types of data and then can put into the systems which are called as data lakes. Now, what are data lakes? Now, data lakes are little advancements of data warehousing solutions. They are exactly data warehousing solutions, but enabling different types of data to be stored in the storages, right? Initial data lakes used to create on Hadoop systems like Hadoop, HDFS, and other things. But nowadays, people are using cloud solutions like AWS, Azure, GCP, and so on, right? GCP. So nowadays, people are using these solutions, AWS, Azure, and GCP, and other kind of solutions for storing the data lakes. And what we are seeing here is the trend which is initially originated for doing data analysis on the RDBMS tables, slightly shifted to nightly jobs, then shifted to data warehousing solutions, and it really worked for quite a long time on data warehousing solutions. But then, because the emergence of multiple data stores like images, videos, log files, sensor data, textual data, and other things, people have now created something called as data lakes. So there is a lot of work here, right? So you need to do the data ingestion, you need to do some data transformation, pre-processing, and all that stuff. This entire area of work is called as data engineering. Okay, so this entire area is called as data engineering. Data data engineering, you would be SQL skills, data engineering, where you would be required to know some data ingestions and some Linux related background, some admin related background. So a person who is a data engineer would need to understand all these things, like how do you do the transformations, how do you do data ingestions, how do you do, there are again multiple tools which are used, the tools like Scoop, Kafka, Flume. There are a lot of tools. I'm not going to go in detail, but just imagine that there are a lot of such kind of tools available which help us to do the data ingestions and will be stored in the Hadoop system or AWS or Azure or any other kind of cloud systems where this entire data can be stored. All right. If you have any questions, please use the chat window to post your questions. I can take the questions and answer accordingly. I hope you guys are following. So far, so good.
Yes.
Perfect. Thank you. Thank you. So what we are understanding here is, okay, so the data lakes are started created and data is dumping into the data lakes. Now, if I want to analyze the data, now what is the next procedure? So we after the data is dumped, then people created something called as exploratory data analysis. So exploratory data analysis is a technique in which you're trying to read the data from all these data lakes. Whatever raw data which is dumped into the data lakes, you will read the data and then you try to understand the data. You try to identify what are the important features of this data, what are the important columns, what are the non-important columns, which columns need to be transformed, which column needs to be deleted. So you need to do a lot of pre-processing steps here. While doing that, you will face that there are a lot of missing values. You might need to do some missing value imputation. You might need to apply some different techniques for transformation and other things. So here you would do something like pre-processing, data pre-processing. You will do some transformation. If there are any missing values, you do missing value imputation, missing value imputation. Missing value imputation in sense it is the like treating the missing values. Then you might have to do some encoding. You need to do something like scaling, standardization, normalization, I might do a wrong spelling, but ignore me. So here what we're trying to do is we are trying to apply a lot of techniques which will help us to do pre-processing, transformation, missing value imputation, applying different types of encoding technique like one-hot encoding, label encoding, different scaling techniques, normalization, standardization. So all these techniques will be used to prepare the data in the right sense. Now, this is a very, very tough task because this takes a lot of time, because applying models is only a small part of your entire data science lifecycle. We have to do a lot of pre-processing. We have to create right set of data points and other things, which is very, very important. Now, after we do this entire exploratory data analysis, then we go and apply your modeling technique. The next section is your data modeling. I can call it as modeling or algorithms. So you apply your algorithms in this modeling process, and this modeling process is an iterative process. This is not like a one-time activity. This is an iterative process, and in this iterative process you try to applying different modeling techniques. Different algorithms will be used. We use supervised machine learning, unsupervised machine learning, and different kinds of techniques will be used. And using all those different techniques, you would apply different models. So you can use supervised. Within supervised, we have classification. Then you have regression. Different techniques will be there. Then you'll have unsupervised. Within unsupervised, we have like k-means, hierarchical, and different techniques will be there. You also have reinforcement learning. Different algorithmic things will be used, different modeling techniques, supervised, classification, regression, unsupervised, k-means, hierarchical. Likewise, I have not written again in the classification, there are like 10 20 models. Within regression, there are again 10 20 models will be there. So we are not going to look at the details of those things now, But just here, just to understand that we have this modeling technique where we'll try to take the data, the transform data from the exploratory data analysis, and then we try to apply these modeling technique. In the modeling technique, we will also do this iteration, which is called as hyperparameter tuning. Hyperparameter tuning. Hyperparameter tuning will be applied, and using the hyperparameter tuning, you will use this entire pre-processing techniques. So what we are seeing here is your data will be gathered. You will do an exploratory data analysis by applying all the pre-processing techniques. Then you will apply the modeling by applying some of the algorithms, and then you tune the model so that it gets better and better. And then once the final model is tuned, then we will deploy the model in the corresponding environment. So typically, we will deploy the model into some kind of a cloud environment. Now I'm drawing some kind of a cloud. Imagine this is an AWS cloud. So you deploy the model on an AWS cloud as an executable. So you will deploy that as an say like an executable. Um, maybe take a blue color or a green color. So you will deploy that as an executable. Now you can call it as an API. And what is an API? You will create APIs using Flask and other kind of different techniques. And what you try to do is you deploy the models as APIs so that these APIs can be consumed by other systems. For example, you have a front-end system which is like a bank, and this bank is predicting whether the customer should be given a loan or not. Okay, so just so there are some inputs. So this is a website. You can go log into the website, provide your details, and you just submit. You just hit a submit button, and what happens is this request comes to your, it calls the API. It is a bidirectional request. It comes to the API, and what it will do is it will try to predict whether the person is eligible for loan or not. So person will give all the good details, like it will give what is his name, what is the age, what is the bank balance, whether he's working, where he's working, whether there are any existing loans and other things. So the person will give all those details, and this system could be developed using say like Angular, front-end Angular or React, or say Python. So these systems will be developed using some front-end application, but it will be invoking an API which is deployed on the cloud, and that API would expect some inputs and give some response. So inputs would be the age, salary, bank balance, current existing loans, and other details. And then it will give back a response saying whether he is eligible for loan. If he is eligible for loan, what is the amount he is eligible. So when I say submit, it will take all the details, get back with the call, and the next page it will show, congratulations, you are eligible for 5,20,000, and if you are okay to take the loan, please click yes, and the amount will be credited in your account. So that's how the process will be. You see this Insta loans and other things, right? So that is the same thing. It will happen in a seamless manner, where you are trying to identify the risk profile of the person by providing all the details, and then based on that the loan will be dispersed to the person's bank account directly. Now what is happening here is whatever model you have deployed here, you will use some things like Flask or Docker, and this entire stuff is called as real-time inference. It's called as a real-time inference. The Y is I'm sorry, inference, R-E-N-C-E. So what is this real-time inference? Real-time inference is nothing but you are trying to do transactions in real time. You're trying to have a front-end system connected. Now this could be a web application or a mobile application where it is calling an API. API is the model extracted from the model. So it will be having the model whatever we created from the data, and that will be having input output parameters. You will have an endpoint where you can put the parameters, and based on the parameters it will get back the result, right? So you would use some tools here, Flask, Docker, and other things, and for deployment onto cloud you would also use some other things, and here we would use this real-time inference. You could also do batch inference, like the way you do batch inference. Let me draw it here. You could also do batch inference. Now, what a batch inference will do is you will still have the same kind of API or whatever. So you'll have a model and you will have the API created. Let me draw it very simply here. So you have the API available. Whatever your model is created, it will have an API, and then you will have input-output files. For example, you will have some input file. You'll give the input file, and then this API would create an output file. So you have input. Now, instead of this is a batch inference. So now what is a batch inference? Instead of giving one record at a time, now you would give a batch of records. Now this could be having 100 applications. It will be having a CSV file with different 100 people worth data, right? So maybe like a bank clerk is collecting all the information of the people who are opting for loans, and then he will create a CSV file, and that file will be uploaded. Then API will take one record at a time, and then for every record it will try to guess whether the person is eligible for loan or not. If yes, the person is eligible for loan, it will also guess like what is the dispersible loan amount, and it will create an output file. Now this is a batch based inference. In a batch based inference, you might again need to use some other tools like of course you would use Jenkins, Flask, and other things, but you would also need some other tools like so Jenkins for scheduling this job. So you will schedule, say that every day say like 1 a.m. 1 a.m. or 2 a.m. in the morning, you will run this job, and every day it will run 2 a.m. in the morning and try to take the input file. Again, this input file will come from the data lake itself, right? So there will be connection between data lake and this batch inference, which the Jenkins will pull the file, and it will do the batch inference, create an output file, and this output file again will be put in the data lake itself, right? So the connection here is the modeling will be done. The modeling will create a model, and we will construct a API out of the model using Flask and other tools. And based on that, you would create this batch inference model, connect using the Jenkins, and which will take the input files, do the process, and then give the output file. And last but not the least, we would also have some data visualization tools. Data visualization. Now, data visualization is also a very, very important aspect of the data science, where you would use some in-house tools like Matplotlib or Seaborn, which are like Python-based tools, but you can also use some third-party tools like Tableau, Power BI, etc., to create reports. Now these reports have to be created because whatever analysis we do, whatever the output we do, if you just give an output as a Excel sheet, people might not appreciate that much. Picture talks more than 1,000 words, right? So if you are able to project that analysis in terms of some picture, that gives a lot of information when opposed to just giving a CSV file. So what people do is they try to create these pictures, and then they try to create the analysis, and then try to visualize the data, and using the data they will try to uh, create different results. So you can draw some various graphs and other different techniques can be created by which you can represent the data. You can show like how the data is projected, what is it trying to depict, right? You can depict from the data saying that okay, it is having a positive trend, negative trend, these many products are sold, these many products are not sold. So likewise, you could do a lot of visualizations based on this modeling, how this modeling is predicting. So all those things we could do using the data visualization tools. And using the tools, you can also create an end-to-end story. You can say like, okay, in past year, this was the sale. Today, this was the sale. And after applying so-and-so business strategy, this is how the improvement in the sale. So all those things can be depicted using the data visualization tools. So overall, what we are trying to see is this end-to-end data lifecycle. We started understanding how it really started in the earlier sense, where the RDBMSs were used for doing all these data operations. Then came the nightly jobs, then came the data warehousing solutions, then came the data lakes, where all the data is dumped into the systems. So we would need a lot of people expertise here, which will enable for doing data operations, transformations, data ingestions, and other things. Then once the data is stored, next process is how do you analyze the data? How do you get the insights from the data? For that, we do exploratory data analysis to prepare the data for the modeling steps. This data preparation is very important because in the raw data, you will have a lot of garbage. When you give garbage directly to the models, you will get garbage results. So the purpose of the exploratory data analysis is to clean up the garbage, create a right amount of data which can be sent to the modeling. Now, once the modeling gets the right amount of data, then using some of the modeling techniques, you would create the models. These models can be deployed onto cloud services. Now, once you deploy them as APIs, front-end systems can consume those APIs, and they will consume the APIs, and they will get back the results. Now, this could be a front-end system or a mobile app or some kind of a link or whatever, where they will consume the API. The API will internally call the model created by these algorithms, and then it will do the predictions. The prediction could be whether the person is having cancer, whether can I give the loan or not, is this email a spam. So there are varied examples or projects which will use machine learning, deep learning, and other modeling techniques, which we'll learn during the course. But what here we are understanding is how are they connected. So the inference can be done in real time or in the batch mode. Real time inference is some system connected, giving some inputs and getting the outputs in the real time. But we can also do the inference in the batch mode, where you can give a bunch of records. Bunch of records will be taken. They will be predicted one after the other, and then you will construct another output, which will be fed back to the data lake system. And last, we have understood the data visualization, which is also an important thing to portray your analysis in terms of some story, so that you can create a story, can weave some insight, and that could be explained to the senior officials or whoever you will be reporting that analysis to. Right? Any questions on this? I'm really sorry. Is the pace okay? Are you guys understanding what we discussed for the past 45-50 minutes? You can use the chat window, please, or You can unmute and speak. So,
Yeah, Sitaram, it was quite good.
okay. Any questions so far?
Do we use any specific tools for the exploratory data analysis?
Yeah, there are tools like NumPy, Pandas, and other things. And scikit-learn, there are tools which we will learn. There's entire section where you need to learn different tools, and those tools will be helping us to understand the entire process.
Okay, thank you.
Anything in this, if you're looking at this, if you're having any questions, it's an entire board filled with information. If you have any questions in this space, just let me know. I will also spend few minutes to just brief you about the structure and other things. But if you have any questions here, please do let me know. You can also use the chat window if you have any questions. All right. So I'll just brief you about the structure and how this entire course would be working. So this would be a 3-month course, roughly around 3 months. The classes would happen daily from Monday to Friday. Timings would be 7 a.m. IST. So this Monday till Friday is also IST timings. So accordingly, if you are in another part of the world, for example, if you are in US, Monday morning would be your Sunday night. So that is how the timings would vary. So from Sunday till Thursday night is what the sessions would be. Friday night, no session. Right, so that's how, if you are in the other part of the world, you have to adjust the timing accordingly. And so we would be covering 20 plus projects. As I said, this is a project oriented course, a project oriented learning. I am very towards learning using a practical approach. So instead of having some theory session, some presentation and something which will feel as good, but when we go into the real world, you will not know like what to do, how to do and all. So what we will do is, throughout the course we would be doing projects. So while we are doing the project, while we're learning the concept through the project, we will understand like how this entire stuff would work, right? So that's the focus. And we will be covering from the basics till the advanced topics. So we will start with some basics about data science. We will do mathematics, math for data science. We will do statistics. We will learn about Python. So this section would cover all the basics. So we'll start with the basics of data science, understand what is data science, where we will use, how we will use. So today's session is something towards that. So understanding the basics. Then we will get into the mathematical concept. We'll learn about linear algebra, matrices, matrix related operations, eigenvalues, eigenvectors, scalars, vectors, tensors. We will also learn about calculus, differentiation, and other concepts which will be used in data science. So we'll understand all those things. Then we will enter statistics. Statistics is also an important topic, where we will understand about inferential statistics, descriptive statistics, different statistical values, measures of central tendency, measures of spread, measures of dispersion, different other things will be understood in statistical concepts. Then we'll come to the Python. Python is the go-to language for doing any machine learning related work. So we will learn about different machine learning related tools. Specifically in Python, we will learn about NumPy, Pandas, Matplotlib, Seaborn. So there are different tools which will help us to write our code in Python. So we'll learn that. And once we understand the Python related stuff, then we'll get into the machine learning concepts. They will do machine learning. Now within machine learning, we saw there are different other techniques, supervised and unsupervised. Within supervised, again, you have classification, and regression. Unsupervised, there are other techniques. So we'll do all those kind of things. Then we will also learn about natural language processing. Natural language processing called as NLP. You will also learn about deep learning. Deep learning is another important area where we will cover a lot of depth there. Then we will learn about cloud computing and DevOps. Cloud computing and DevOps are very, very important. If somebody says that, okay, they are not important or they are not required for data science, they are fooling around. So according to me, you need to understand. So I call this as depth and breadth. So you need to have depth in data science. So you need to have this depth. Now, how do you get DEA? I missed it. How do you get the depth in data science? While we know about all these algorithms and other things, you will know the depth in data science, but you also need to have a breadth. Now, the breadth in data science you would get with this connected tools. You need to know the cloud and the DevOps. So in our course, we will do the end-to-end connections. Like we will also connect how do you do cloud computing for the data science and DevOps for the data science. Now here you might need to learn about some tools like AWS or Azure. Not deeply, but you need to know, like, how you would create data science models using that. And in DevOps, you would know about Docker, Jenkins, Kubernetes, and so on, which will help us to how do you connect this entire containers and the concept of containers, how do you connect them, and all that stuff you would learn with this. Got it? So while covering all these three concepts are very deadly. So while we'll cover a huge amount of depth in data science, but at the same time, we'll be covering the DevOps and the cloud concepts so that you link all these things together and then you create an end-to-end system. You are like eligible for creating an end-to-end data science system, and by that knowledge, you will get the entire scope. All right. So there is an important information from Career IT. So regarding the details of the sessions and what will be the timings of the sessions and whom do you need to contact for any further information. If you have any questions, there are numbers put there, so you can call that numbers, and then they will be happy to help you. Call or message. They'll be very happy to provide you any kind of assistance or any details which you might need to know. All right, any questions? Any general questions? If you have any questions, please either put that in the chat window or you can speak out. We will clarify any doubts which you may have.
I have just one doubt. My basic skill sets, I work as a HANA consultant.
Hmm.
So how this will help me to, grow in the career path? Because what I do, I write the procedures, I do some analytics, uh,
Hmm.
all those things. So I wanted to know that how this data science or entire this scope will help me to, grow in my career.
Right. See, the question, it depends. So if you are looking from a knowledge standpoint, there are two things which you can do, right? So one is from a knowledge standpoint, because HANA also does a lot of analytics and other things, but that's from a tool specific. But knowing this knowledge, like what all things could be done, how do you apply different techniques and algorithms and other things, definitely help you to explore the same things in the HANA world and see if there are any possibilities of doing interconnections and other things in your current work. That's one angle. The second angle is because HANA is then again data related and other things. If you would explore other opportunities within the scope of your company in data science and other things, that will help you to migrate easily from, say, SAP HANA to any of the data science related work, right? So there are two things. So you can still continue the way the work you have done, but that will help you to explore more things in the current work you do. And later, at some good point, you would plan to shift into another area, which would help to better your career.
Oh, okay. Yeah.
Right?
Thank you.
Hi, I'm Achyut.
Yeah.
I am a mechanical engineer. I have
Mm-hmm.
all my experience in automotive domain,
Mm-hmm.
in mechanical engineering or mechanical domain only. But with my interest, I learned Excel VBA.
Okay.
I used to do macros for analysis, data analysis. When I
Mm-hmm.
was doing data analysis, I got interest towards this data science because Excel is very basic and we cannot do much analysis in that. So I started
Correct.
thinking about data science. So can I understand like your session will be completely understandable for a mechanical engineer, or
Yeah.
what are the things I need to learn before start of this course?
Yeah, see, the thing which is important is because you might not have done any coding. If you have already done VBA coding, then it is good. Definitely, you will be able to understand the concepts. But
Yes,
you need to have,
VBA coding I have done, and Python basics also I am aware.
okay, then I think you're good to go. Because if somebody who doesn't know anything about the basics of Python and all, I would recommend them to do a course on Python, get an understanding there, and come back. But if your basics of Python is known, so because I will not be talking like what is a variable, what is a function, and all things I will not be touching on.
Yes, yes.
I'm expecting that people understand that, and we will be talking about Python basics. As I told, we will be talking on Python, but using the tool Python for solving data science problems, that is what we will be talking on. So that will tell, like, if I have a data, how do you export data, how do you analyze the data, how do you transform it, how do you get insights from that. So all those things will be learning from a Python's perspective. So it will be doable because I have taught many students who are in the similar lines, who are from a healthcare domain, finance domain, done some BSc and other things, and mechanical domain. So definitely they will be able to understand. But I would recommend to put a little more effort from your side, because when compared to other people, probably you might be at a little disadvantage. So I would really recommend to put a good effort, and I will be helping you to understand all the concepts in a great detail. And we will be doing project oriented learning. So that means that as and when we are learning a specific topic, we'll also do an associated project. So that will clarify a lot of doubts. So if you have any doubts also, those doubts could be clarified in that sense.
Okay, thank you.
Any other questions?
Thank you, Sitaram. Just a generic question. So, what is the basic difference between a
All right,
data
so
scientist? Oh, sorry. Can you hear me? Hello.
what is the base instance? What should know as a prerequisite?
No. So, what is the difference between
I'm sorry,
data
your voice was
scientist and?
breaking. Could you repeat the question?
Oh, sorry. Can you hear me now?
Yeah, a bit. Yeah, go ahead.
Oh, sorry. I was asking, like, what is the difference between the data scientist and the engineer? I mean, data engineer.
Yeah, so this picture, whatever we have gone through, this will give you an overview of people who are working in this area, right? In this area, we can call them as data engineers. The people who are working with data ingestion, data transformation, data storage, management, and other things is the primary job responsibility of a data engineer. A data scientist is the one who is doing exploratory data analysis, some amount of transformation, applying the models, deploying the models. This work will be taken care by the data scientist. Of course, a data engineer can become a data scientist. Data scientist can become a data engineer, depending on the type of work we do. If you are working for product companies or probably small companies, then it will be all mixed fruit juice. So people who are working on data engineer will work on data scientist and work on modeling, deployment, cloud computing, DevOps, everything, right? But if you're working for a bigger corporate companies, you would have specific job roles. Like there will be a data engineer, there will be a Linux engineer, administrator, there will be a data scientist, junior data scientist, there will be a ML engineer who will be deploying the models, creating Docker containers. There will be AWS DevOps engineer, there could be a front-end UI developer who will be working on Angular, React, or something else. There will be data visualization Tableau developer who will be working on the visualization part. So depending upon the organization we work, these job roles will be independent, different, and separate. But if you work for a small company, there will be a lot of overlap. But the job roles, there will be a lot of overlap, right? So this area is what we call as data engineering. The persons who work on this area would be data engineers. People who work on the modeling part and other things, we call them as data scientists. Did it answer the question?
Yes. Thank you, Sitaram.
Okay. Any other questions? All right. I hope you got some insights on what we are trying to do. So we will start the course from 8th of March, which will be from the next Monday, coming Monday. So if you're interested, please talk to the organizers from Career 80. They will be happy to help you with any of the questions and clarify any doubts. All right. Thank you very much and have a nice day. Have a nice weekend as well. And I hope to talk to you again. Bye-bye.
Thank you.
Yeah, thank you. Bye bye.
Bye.
Thank you.